All right, so in this lesson, we're going to be talking about the quadratic formula and what we call the discriminant and what that discriminant will mean as we're doing the quadratic formula. So there's three different cases when it comes to the quadratic formula. So I'm going to zoom down right here. So the quadratic formula, in order to do it, you need it to be in standard form. You need to be able to identify the A, the B, and the C. Now, a can't equal 0. Obviously, if it equals 0, that gets rid of the x squared, which means it's not a quadratic anymore. And then we use the formula x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all divided by 2a. Now, what we're going to focus on right here at the beginning is going to be what we call the discriminant. So the discriminant is the b squared minus 4ac. That's what's inside the square root. Because when the number inside the square root is different, that's going to change how many solutions we can have. So we're getting into the point, we've kind of talked about it previously, but we're getting into a point now where we're actually going to start finding the solutions. Now the solutions are the x-intercepts, okay? So if the solutions are the x-intercepts, then that means that we can have more than one solution. We can have just one solution, or we can actually have no solutions. And the way that that happens is if we don't have any place where that graph or that parabola is going to cross over the x-axis. And the reason that that would occur is because we have a certain type of discriminant. So the first one that we're going to be looking at, so if we plug in all of our numbers and we get b squared minus 4ac and it's greater than 0, so that means it's positive. That means it's going to have two solutions. So if this is my x-axis, that means that it's going to cross the x-axis twice. So those two solutions, those two x-intercepts, that means that it would have a positive discriminant. So if my discriminant is greater than 0, that means it has two solutions. So if I look right here, I know that my A is 12, my B is 5, and my C, whoops. So when I look at this problem, the first thing that I notice is that it's 12x squared plus 5x equals 4. So we want it to equal 0. So in order to equal 0, we're going to subtract that 4 back over, and we have 12x squared plus 5x minus 4 equals 0. So my A is 12, my B is 5, and my C is negative 4. So we're going to calculate the discriminant. So we're going to say 5 squared minus 4 times my A is 12 minus my C, which is negative 4. All right, so I'm going to go to Desmos. I'm going to pull the calculator up. So we had 5 squared minus 4 times 12 times negative 4. So 4 times 12 times negative 4. And we can see that that is, in fact, going to give me a positive number. So that number is 217. So we know that this is going to have two real solutions, which means it's going to cross the x-axis twice. So if I actually graph the original, well, not the original, the one where we transferred it, the constant over. So we're going to say plus 12x minus 4. We can see that it does, in fact, cross the x-axis twice. Now, we will get to a point where we find those in just a second, but we do have two real solutions. Real solutions are when they touch the x-axis. Now, we can have real, and we have what we call rational, which is any number that can be turned into a fraction. We can have a real and what we call irrational, which is, let's say, like the square root of 17, and that's going to produce a non-terminating decimal. It's basically decimals that are going to have different numbers, and they're going to keep going and keep going. It's never going to stop. So a non-terminating decimal, it's not going to repeat the same number. So let's go to the next case that we have. So the next case that we have is going to be what happens when my discriminant is equal to 0. Okay, so when my discriminant is equal to 0. So if I look at this problem, I have 2x minus 8x equals negative 16. So I'm going to add 16 over. And that's going to give me x squared minus 8x plus 16 equals 0. So that means that my a value is going to equal 1, my b value is negative 8, and my c value is 16. So make sure that whenever you have a b value that's negative and you just square it, you put in parentheses, because if not, it's not going to do the order of operations correctly. So I have negative 8 squared minus 4 times 1 times 16. So if we do negative 8 squared minus 4 times 1 times 16, I get 0. So when that discriminant equals 0, that means that we are going to have one real solution. So what's going to happen with that is whatever the quadratic may look like, it is going to touch the x-axis, but it's only going to touch the x-axis one time. So let me adjust this so you can actually see it properly. But it's the vertex is what's going to land on that x-axis, and it's only going to hit it at one point. So if I put this into Desmos so that we can look at it graphically, so I have y equals x squared minus 8x plus 16, I can see that I have a x-intercept, and that x-intercept is only hitting the graph only hitting one time. And that's because if we actually were to factor this, so two numbers that multiply to give me 16 but add to give me negative 8 would be negative 4 and negative 4. So it's actually a perfect square trinomial. So when do we have one solution? Well, the majority of the time is when, or it is when we have a perfect square trinomial, or if we have a difference of squares situation. All right, so that's our second case, is when it is equal to 0, we have one solution because it's the same number twice. And then our last case is what happens when it is negative. So remember, the number that we're looking at is the number that's underneath the square root for the discriminant. So under the discriminant, we cannot have a negative number. So if it's less than 0, that means it's negative, which means it's imaginary. So the example for this one that you're going to have is if I have my x-axis, then that means that it's not going to have real solutions. It's going to have solutions that are never going to actually cross over, or x-intercepts are not, the parabola is not going to cross over the x-axis. So they're going to be two solutions, but they're two imaginary solutions. They're not real solutions. So again, to put this in the correct format, I'm going to add the 4 over and get it equal to 0. So I have 2x squared plus 3x plus 4 equals 0. So my a is 2, my b is 3, my c is 4. So we're going to say 3 squared minus 4 times 2 times 4. So I'm going to put this one, and I'm going to say 3 squared minus 4 times 2 times 4, and I get negative 23. So since it's negative, that means that it's never going to touch the x-axis. I'm not going to have real solutions. And I can visually see that if I type it in. So I have 2x squared plus 3x plus 4. And I can see that it never crosses the x-axis. So the cases that you need to remember is if my discriminant is greater than 0, it's two real solutions. If my discriminant equals 0, it's one real solution. And if it's less than 0, that's negative, so it's no real solutions, because technically it's going to come out to have an imaginary number. Now, we're actually going to talk about how to find the solutions this time, and we're going to find the solutions using the quadratic formula. Now, the quadratic formula can honestly be used in any scenario. You do have to have it in standard form, but any of the forms that are given, you can always multiply it out and get that standard form. So the quadratic formula is always a go-to if you're trying to find your solutions. So for this one, I have an a value equal to 1, I have a b value that's equal to negative 2, and a c value that's equal to negative 8. So if I want to find my solutions, I have x equals negative b. So the formula is negative and the number is negative. So then we're going to have plus or minus, and we're going to do the square root. And we're going to have b squared. So we're going to take negative 2 and square it again. Minus 4 times 1 times negative 8. So let me extend that square root. And that's going to all be divided by 2 times a. Now I know this looks like a lot, but really we just need to simplify it. So a negative, negative 2, that's going to become plus 2. And then I'm going to go ahead and type in the discriminant. So the discriminant part, I'm going to go ahead and type that in and get that value. So we're going to say negative 2 squared minus 4 times 1 times negative 8. And I get 36. So 36. So I'm going to take the square root of 36. And that's going to be divided by 2 times 1, which is 2. Now, I am going to simplify this, so I can take the square root of 36. The square root of 36 is a perfect square. So we should have two solutions, two real solutions, because the square root of 36 is positive. So we have 2 plus or minus 6 divided by 2, which is going to be 2 plus 6 divided by 2 and 2 minus 6 divided by 2. So I'm going to calculate both of them. So I'm going to say 2 plus 6 divided by 2, and I'm going to say 2 minus 6 divided by 2. So 2 plus 6 is 8, divided by 2 is going to give me 4. 2 minus 6 is going to give me negative 4 divided by 2 is negative 2. So I have two x-intercepts or two solutions, which are going to be negative 2 and 4. So remember the little squiggly brackets or set brackets where we can list the solutions. So my solutions are x equals negative 2 and 4. And if I look at it graphically, I can verify that. So we had minus 8 there. And I can click and see that I do have x-intercepts at negative 2 and 4, which are my solutions to my quadratic. So what does this solution mean? That means that if I take this negative 2 and I substitute it here and here, it will equal 0. That's a true statement. If I substitute 4 here and here, it will simplify and equal 0, which is a true statement. For number 2, I have 3x squared plus 5x minus 4. So I'm going to take my quadratic formula, and I need to identify my a, my b, my c. So my a is 3, my b is 5, and my c is negative 4. So I'm going to say x equals negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 4. And that's all going to be divided by 2 times a. So 2 times a is 2 times 3. And we're going to simplify this. So we're going to get negative 5 is plus or minus. So we need to calculate 5 squared minus 4 times 3 times negative 4. So we're going to say 5 squared minus 4 times 3 times negative 4. And we get 73. Now 73 is positive, so we are still going to have two real solutions, which means it's going to cross the x-axis twice. The only thing that we've really got to focus on is the fact of how do we simplify this. So remember when we started our lesson previously, when we did complex numbers, we may need to simplify this square root. So I really need to see, do I have any numbers, obviously, that will divide? So I have, obviously, 2 is not going to work because it's not odd. 3, 4, 5, 6, 7, 8, 9. Obviously, not 10, not 12, not 13. So if we're getting to this point, we should see that the square root of 73 is a prime number. So there's no way to simplify this further. My two solutions that I have are going to be x equals negative 5 plus the square root of 73 over 2 or over 6. And we have a solution x equals negative 5 minus the square root of 73 over 6. So again, if I type that into Desmos, I can actually look at those numbers, and I have -5 plus the square root of 73 divided by 6. And then I have -5 minus the square root of 73 divided by 6. And those are my two values. So if I type this in and I say 3x squared plus 5x minus 4, I can see that it crosses the x-axis, but it's irrational numbers, which is why that square root of 73 is creating an irrational non-terminating decimal. So if I look right here, I have the -2.257 blah blah blah, and I have the 0.59, and of course Desmos is going to round it because it can't continue the decimals on. So we did find the correct answers there. All right, so for number 3, I have A equals 1, I have B equals 6, and I have C equals 9. So I'm going to do my quadratic formula. I'm going to say x equals -b, which is going to be -6, plus or minus the square root. And we're going to say b squared, so 6 squared minus 4 times 1 times 9, which is a times c. And that's all going to be divided by 2 times a, which is 2 times 1. So again, we're going to simplify. We're going to say -6 is plus or minus, so we need to do 6 squared. And we're going to do 6 squared minus 4 times 1 times 9, and that equals 0. So we have the square root of 0, so that should remind me that if it equals 0, we should have one solution, which is 2. So at this point, the square root of 0 is still going to be 0, so we have x equals -6 divided by 2. That plus or minus goes away because the square root went away. So my final answer here is just the answer -3. So x equals -3. And again, this is a perfect square trinomial, which is why that's happening. So if I put this all together, that gives me -3, which essentially is the same thing as saying x plus 3, because it's going back in the parentheses, x plus 3. Whoops. Because they're the exact same, producing the same quadratic in factored form. All right, and my last one here. So I have 2x squared minus 3x plus 5. So I have a equals 2, I have b equals -3, and I have c equals 5. So we're going to do x equals -3 plus or minus the square root, and we're going to do -3 squared minus 4 times 2 times 5. And then we're going to divide that all over 2a, which is 2 times 2. And again, we want to simplify, so we're going to say +3 plus or minus. So we're going to do -3 squared minus 4 times 2 times 5. I believe it was times 5, yes. And we get -31. So that negative means I have no real solutions, which means we're going to have two imaginary solutions here when we simplify. So I have the square root of -31, and that's all being divided by 4. So remember, when I have the square root of -31, that's the same thing as saying the square root of -1 times the square root of +31. So we're going to take that I out. So we have 3 plus or minus I. And 31 is a prime number, so we're going to have to leave it alone. The square root of that over 4. So I have two solutions, but those two solutions are imaginary solutions. So they are imaginary, which means that they will never cross the x-axis. And they're imaginary because we had that negative square root, which has I. So we have x equals 3 minus I, square roots of 31 over 4. So we do still have two separate pieces. We have what we call conjugates. We have the plus and the minus. However, they are not real solutions, which means that we would not be able to see them on the actual x-axis. So we have 2x squared plus 3x plus 5, which you can see that they are not going to cross over the x-axis, which means I do not have real solutions, I have imaginary.